All right, we're about to learn physics. Rocco, are you ready to learn physics?
Yeah.
Jay, are you ready to learn physics?
Yep.
Excellent. This is little Rocco. He's excited and running. You know why he's excited, Jay?
He's running to the store.
He's running to the store. You know what he's going to buy? What are you going to go buy, Rocco?
A video game.
What video game?
Professor Layton and the Azron Ladycy.
Can't wait to play that. All right, here, running. You know how far you run to the store? You run 20 meters because you live right next door. You love this store. You moved in right next door. But when you get to the front door, you know what happens, Rocco?
Yeah.
What?
I lose my money.
You totally realize you dropped your money. Yeah, you dropped your money back here. 15 meters from the front door. 15 meters back that way. So, Jay, how far did Rocco go?
35 meters.
35 meters. Rocco, how far did you go?
5 meters.
You guys are disagreeing. What's the right answer? How far did you go?
It's too vague.
It's too vague. This question sucks. Boo!
Yeah, hold on. Wait, how far did I go to where?
Exactly. Rocco traveled 20, then 15, 35 meters, but also only made it 5 meters from where he started. So this question's too vague. In physics, you've got to be specific or you're going to fail and life's going to suck. So we need to be specific. We need two different terms. One term that tells us like this total path, one term that tells you how far you ended up from where you started. Those terms are these. Distance is total length of the path. So this is the distance all the way there. So Rocco, what was your distance?
35 meters.
You know what letter we use for distance?
D. Lowercase d.
Lowercase d. And your distance here was 20 plus 15. You add up all the parts of the path. Just add them all up. You get 35 meters. The other way to measure how far something went is the displacement. And displacement is the difference between the final position and the initial position. Hey Jay, where's Rocco's final position on here?
5 meters from where he started.
It's right here. There's the final position. Where's the initial position, Rocco?
What does that mean?
It's the position where you started.
At 0 meters.
Right here, yeah, exactly. There's your initial position. So the difference between these two, right? My x initial is my initial position. I'm going to use x for position. And my x final is my final position. So if I wanted to put this in an equation, what would the displacement equal? What would be a formula for it, Jay?
D equals x initial minus x final.
Oh, Jay, you made the mistake almost everyone makes. Look at, you know what the problem is, Rocco?
What?
This is x initial minus x final, but displacement is the difference between final and initial.
Oh no.
Oh.
So what's wrong, Jay?
X final minus x initial.
Dude, it's got to be x final minus x initial always. I'm glad you messed that up. Other people mess that up. Always the final minus the initial, otherwise you're going to get your sign wrong. And we don't use D for displacement. That'd be dumb. Why?
D for dumb.
Yes, true.
D for dirt.
But we already used it for distance. If we use it for displacement too, like how are we going to tell what we're talking about? We need a different symbol. The symbol we use is delta x. Oh my gosh, there's a triangle in there. This little triangle is delta. You know what delta stands for, Jay?
Nope. Displacement.
Dell computer. I don't know.
Derpy.
Dell computers.
Derpy.
Delta. This
enchilada.
symbol. Oh yeah.
Leftover.
Ew.
No.
Okay.
Tomato. Anacondas.
Brilliant. That too. But delta, this symbol delta just means the change in or the difference in. I'm going to call it the difference in. You know why?
Why?
Because we called it the difference right here. And change is the same thing. The difference in. That means if you had, give me a random letter.
Z.
Delta
Q.
Z. You know what delta Z would be?
What?
The difference
Z
in Z.
final minus Z initial.
Can it be
You know what
any
Z
letter?
means?
What?
I have no idea. But if I knew what Z meant, I could take delta Z. It'd be final minus initial. Delta, you could have anything in here. You could have like delta N. You know what N is?
Delta 2.
Some point.
Just kidding.
I have no idea. But if I took delta N, it'd be the final minus the initial. You know what it isn't?
What?
The initial minus the final,
yeah.
so don't make that mistake.
Well, fine.
So we come up here. In this case, so delta x is the symbol we use for displacement. J. What is Rocco's displacement in this case up here? What would be the displacement?
5 meters, I suppose.
That's right. Delta x is 5 meters. You got to be careful. Is it positive or negative 5 meters?
Negative 5 meters.
Why?
Because he came back 5 meters.
Oh, Jay.
Oh no!
Oh,
my
Jay,
gosh! I made
Jay,
the mistake.
Jay.
I made this.
It's final minus
Big
initial, so
problem.
final minus
Sorry.
initial 5 minus 0 is 5.
5
I'm
minus
sorry.
0. You know what we got to
I
do?
am disgraced.
It's kind of hard to say. I don't have any numbers in here, but I can just call my x initial. You know what I like calling x initial?
0.
0, because I love zeros, because they're like easy to deal with.
They're like happy faces.
Oh yeah, dude, that's why I like them. And this x initial is 0. That makes this calculation easier, because if x final would be 5 meters, then the difference, delta x is, what is it, 0 minus 5 or 5 minus 0?
5 minus
5
0.
minus 0.
Because it's final minus initial.
Final minus initial. 5 meters minus 0 meters is positive 5 meters. People mess up that sign. You know why they mess up that sign?
Why?
Because they do initial minus final. You know why they do initial minus final?
Because
that's the
initials
mistake I made.
first.
Because usually,
Initials first.
yeah, usually you get the initial value first. Like in a problem, it'll tell you like you start at. Let's give different numbers. We're gonna make this hard. I don't know if you guys are ready.
Okay.
Let's say you did this again, but I said x initial was negative 15 meters, and x final was negative 10 meters.
Ooh.
And now people are like, oh man.
What the?
They're like, I don't know what to do. I'll just try them both.
25?
Maybe? No?
Negative 25?
No.
If we wanted to do x delta x here, look at delta x would be what, Jay? What is it going to be? How would I calculate it?
It'd be final position.
Yeah,
X
which
final.
is what?
X final
It's always
minus X
final.
initial.
Yeah, and so what would I plug in for my numbers here?
You'd have negative 10 minus negative 15.
Minus negative 15. There's another negative in there. You know what negative 10 minus negative 15 is, Jay?
Negative 10 plus 15, which makes 5.
Dude, it's positive 5 again. So it doesn't even matter. As long as you end up, check this out. Important, note, important. As long as you end up 5 meters to the right of where you started, your displacement's always going to be positive 5. What would happen if you ended up 5 meters to the left of where you started?
Your displacement would be negative 5.
It'd be negative 5. Anytime
So
you end up to the
negative 5
left,
minus 0.
the displacement's negative. What if you ended up above where you started 5
What the-
meters? Then what would the displacement be?
Sky 5. I don't know.
We still call it positive 5
5.
because up is like the positive direction.
Oh, like in a coordinate plane.
Exactly, like a coordinate plane. Up is positive, right is positive. That's negative. That's not positive. Left is negative and down is negative. So if I ended up 5 meters below where I started, I don't want to know how that happened. My displacement will be negative 5. Makes
You're
sense?
underground.
Easy, right?
Yeah.
Yes.
Wrong.
Kind of.
Oh.
This gets a little trickier. You know why?
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 Let me get rid of this. Let me get rid of all
What's
of that.
the answer supposed
This
to
is
be?
tricky because these are two different things. Displacement, notice, you had to be careful. If you got that like order wrong, this could be positive or negative. But distance, total length you traveled, is always positive, and this is because one of these is a vector and one of them is not a vector.
Vector.
Yeah, that guy.
Vector.
Displacement is a vector. This is very important. And distance is not. You know what it means to be a vector?
It can be
An
positive or
arrow
negative.
traveling in basically a ray. I don't know.
A vector is a quantity in physics that has both magnitude.
All right.
Magnitude, and magnitude is a fancy word. It's so fancy, but it's just another word for size. So the magnitude of something is just giving you the size. It has both magnitude and direction.
Ooh.
Direction, which means it has a direction. And displacement does have a direction. Remember, Rocco moved 5 meters to the right, or 5 meters to the left.
Or
Distance
35.
didn't have a direction because it was like just total length of the path. First he went forward, then he went back, How are you going to assign that a direction? You can't. But if you're just talking about final position and initial, you can always, if I say my initial's here and my final's there, you can always draw a vector from the initial to the final and say that's the direction. So vectors have a magnitude, which is a size, and a direction. So if you ended up 5 meters, if your displacement was -5 meters, just the 5 is the magnitude. So just the 5 by itself, that tells you how big the displacement was. Basically the length of the arrow. And the sign here tells you what? Rocco, what does that tell you?
Delta?
No.
What's the other part of a vector
It
besides magnitude?
direction.
Direction.
Direction. How's the negative tell you direction? What direction is negative?
Left.
Left, dude, because left is negative. Or could be down if you're talking about vertical displacement. And if it's positive, right or up. Or instead of saying -5 meters, you could say that it's 5 meters to the left. If you leave off the negative, you say +5 meters to the left. But writing to the left, to the right, to the up and right is boring and takes too long.
Right.
So usually we just use shorthand. -5 will mean 5 meters to the left or down, and +5 means 5 meters up or to the right. Distance is not a vector. You know what we call things that aren't vectors?
Non-vectors.
Yeah, you could have, but we gave it a special name. It's called a scalar. Scalars are things that are not vectors. They don't have both magnitude and direction. They only have what?
Magnitude.
Stuff.
Only have magnitude. That's it.
Oh.
They only have a size. That is to say, remember the distance you
Oh,
walked?
yeah.
Distance was 35 meters that Rocco ran.
That's the
but
scalar.
That's it. It's not 35 meters right or left because he went right and left. Distance is just a scalar, only the size, no direction. There are other things in physics like this. Rocco, if I told you that some kid was 6 years old, is that a scalar or a vector?
Scalar.
Scalar, why?
Because it doesn't have direction.
It doesn't, because if someone asked you how old you are and you said, I'm 6 years old to the left, that would sound just stupid because you aren't 6 years old to the left, you're just 6 years old. That's a scalar, no direction. It makes no sense to have a direction there. If I asked someone's mass, what's your mass? And they said, it's 53 kilograms to the right.
What?
I'd be like, what? You obviously don't know the difference between scalars and vectors because 53 kilograms is just a scalar. There's no direction. A vector, besides displacement, might be force.
42.
I can push on someone with 82 newtons to the right. If you push on someone, if you come in and push, you could push to the right, you could push to the left, you could push up, you could push down. Force is a vector. Another vector is velocity. Velocity is a vector because I can
we do that next
drive or run to the right or run to the left. I could run down with 25 meters per second right or 18 meters per second left, which I could call -18 or 18 meters per second to the left. Velocity, force are vectors because why, Rocco?
Because it has direction and magnitude.
Because it has direction and magnitude. And scalars only have what, Jay?
Magnitude.
Magnitude.